Okay, hey, so the next discussion is about tools, okay? And I wanted to bring Dave in and have him talk about the 3DS vision of the tool set that's out there. Now, we're not advocating that that is the answer. What we're advocating is you've got to think about this in a certain way and be able to do that. And most of the companies, companies for that are currently working in the aviation business are utilizing tool sets. Nick mentioned CATIA, but a lot of the other tool sets as well. So Dave's here to kind of walk us through what a tool set might look like and how they really think about solving the problem. Dave, you're up.
Thanks, Dr. Lewis. As Dr. Lewis said, my name is Dave Guzinsky, and I'm with Dassault Systems. And we're not going to be making a sales pitch on using the 3D Experience platform or CATIA or any of that other kind of stuff. But what we are going to do is we put a lot of thought behind how would a system like the 3D Experience platform and all the functional domains that it covers, how would it be utilized in an acquisition program? And what we did is we took the acquisition process, we laid out those timelines and the interactivities that happen within the government agencies, then the interactions between the government agencies and the respondents during the RFP process, took it all the way through into a program of record and then on into sustainment, manufacturing, and ultimately sustainment as well. So we're going to show you a video that kind of illustrates how you would execute a model-based digital enterprise utilizing something like the 3D Experience platform, but again, it could be used other ways as well. Garrett Thurston is going to be helping me. Dr. Garrett Thurston, if anybody doesn't know him, he's done a lot of work on future vertical lift, both with the PEOs as well as with the OEMs. And then also on the phone, I have Andrew Bonica. And Andrew is going to be keeping the timing. So whoever is holding our video, when you hear Andrew ask you to pause, we may pause at a moment on the video so that Garrett and or Andrew can illustrate a key point. So with that, Garrett, you want to get started?
Just a couple of comments to augment what David had presented. So the concept here, one of the challenges we have with digital transformation is, some of the things that Dr. Lewis spoke about, and that's really understanding how to be able to do futures analysis on what that future operating mindset is. And if we have failures of imagination, tying ourselves back to past ways of working, ICDs was a good example, then we're potentially unable to establish what that future operating model looks like. And frequently we'll hear things like end state architecture. Well, end state architecture imposes potentially an unnecessary boundary over where you're going to end up. And so what we tried to do was take something that was realistic and achievable, but walk through what it might look like in a digital end-to-end, regardless of what the infrastructure, tool sets, integrations are. A lot of times we use tools as a proxy, but typically when we think of tools, we think of things that have a schema all its own and a set of services all its own that's built for purpose. When we start to think about digital connectedness versus what Dr. Lewis talked about, which is digital continuity, that is that the digital data will be available for you as it's needed throughout its entire life cycle. And so there's a very definite definition there versus when we use it colloquially. So one of the things that we really have to consider is making sure that we're freeing ourselves from those tool mindset boundaries and making sure that we're moving forward and putting aside some of those cognitive biases that inevitably are part of our human frailty. So what we tried to do in this case is say, well, imagine that we don't have any of those cognitive biases, that we don't have the people hiding under the table who hate change. We don't have the things that are problematic. And we talked a little bit about the innovators and the smalls versus the bigs. Well, the smalls are also the early adopter potential, right? So that innovation is potentially early adopters because the bigs have infrastructural challenges in moving from one thing to the next. And so that innovation is also about that adoption model. So kind of in that mindset, let's kind of take this unconventional tool presentation and then sort of allow it to free us from the anchoring biases that we had from yesterday. So But with that introduction, I guess I'd like to kick off the video. And the video is kind of standalone. And so, you can look at it, and the idea is to precipitate the conversation so that the subsequent meeting, where you say, hey, there were some things about, in that video that I think we need to talk about. Dr. Lewis talked about model curation, but we have to talk about digital curation, right? So we have to think about how all these things fit together. And as such, it ought to be able to be a good end-to-end thing that allows us to not just tackle the next thing, but to start reasoning about the entire life cycle. So hopefully that makes some sense and contextually. And when you see this non-conventional thing, you won't be going, what the hell is this? So anyway, so let's go forward.
We live in a world of increasingly complex and volatile threats to our national security, with challenges from adversaries in every operating domain. The United States Department of Defense is addressing these threats by investing in a resilient and rapidly innovating joint force capable of preserving the peace through strength. It's said we can't prevail against tomorrow's threats with yesterday's assets and equipment. So the U.S. Defense Department is building our readiness to match any adversary with superior capabilities in any contested environment. And Dassault Systems is playing a key role in that effort. This presentation will show how the 3D experience from Dassault Systems provides the innovation platform to build that competitive advantage for our troops with superior resilience, faster innovation, higher availability, less dependence on single sources, and greater financial stewardship. In accordance with the DoD's Instruction 5000.02 for the operation of the Adaptive Acquisition Framework, across all 5 phases of this major defense acquisition program, the 3D Experience platform delivers a strong multi-strand unbreakable digital thread that enabled traceability forward and backward to the requirements and trade-offs made throughout the life of the program's assets, across all engineering domains, now and for decades into the future. A model-driven environment for every phase of the program. A virtual verification and validation platform that lets program managers use the latest physics-based simulation models to virtually simulate designs and processes, to discover issues in the virtual world before they become time-consuming and very expensive to address once they're in the physical world. An open environment that allows you to work across a family of systems, even extending legacy systems where necessary to interoperate with the latest tools. All this on a single object-oriented integrated data model that provides the authoritative source of truth at the center of the DoD's digital strategy. Let's take a look at our eVTOL example and see how the 3D Experience platform provides the competitive edge the program needs. In the materiel solution analysis phase of this major defense acquisition program, the program office will select the most promising technology that will address the unmet needs. Here, the Program Executive Officer, or PEO, receives the initial capability document from the JSIDS process. As the team grows, everyone has access to a single, secure, real-time, authoritative source of truth, no matter where they're located. The various missions, seen here on the mission cards and documented in the ICD, will help guide every phase of the acquisition program. The PEO manages every aspect of the program: schedule, cost, risk, resources, and technology development, all from a dashboard on the 3D Experience platform. Right from the outset, mission-driven stakeholder requirements are expressed as models and captured in the platform, and will feed the system requirements and the physical requirements, which guide all the analyses of alternatives and associated technical measures of evaluation. On the 3D Experience platform, there is complete traceability between user requirements, the use cases, the concept definition, the high-level system requirements, and beyond. The 3D Experience platform reinvents the acquisition process by providing an integrated platform to model the complete life cycle of an asset, from concept to operations. The modeling of the missions is the starting point. It provides an integrated framework to model every aspect of the mission through every phase of the program. Mission modeling is the first strand of a digital thread that runs unbroken through the life of the asset. No Magic Cameo and CATIA Magic provide state-of-the-art capabilities to model the mission with a model-based systems engineering methodology. This portfolio provides the best-in-class unified architecture framework implementation using the industry standard SysML language. This enables the basics of mission modeling and simulation. But operational and functional simulation are not enough to fully analyze the mission. To do so requires multi-physics and multi-scale simulation. As the mission is being analyzed, some concepts of operations are being identified. In parallel, multiple systems of systems and systems alternatives are also being considered. The multi-discipline and multi-scale trade-off analysis capabilities of the platform allow the team to explore millions of options and configurations, to find the best winning concept and validate the system's requirements. This is essential to develop a consistent and sustainable family of systems and the related systems of systems with a strong level of performance and interoperability. As the team enters the technology maturation and risk reduction TMRR phase, the abstract conceptual systems architecture identified in the previous phase informs the development of the preliminary systems design
We're
for the
about to
3
pause,
mission
Gary.
variants of the eVTOL.
I got anxious.
To enable the bidders on this program to benefit from all the modeling work done to date, the RFP is issued in the form of models for each of the mission variants, saving time for the program office and providing for a more robust RFP. As the 3 OEMs respond to the RFP with different proposed configurations, the program office evaluates each option against their assessment of functionality, cost, schedule, and risk, always tying back to requirements at all levels. The 3D Experience platform allows the program office to make their selection with confidence they've made the best choice. Once the prime contractor is awarded the program office refines the schedule, and the digital thread that started at the very beginning extends unbroken into this phase of the project. Let's take a closer look at how the 3D Experience platform was used in the TMRR phase. The 3D Virtual Twin is a language for all. The Virtual Twin experience helps all stakeholders to share ideas and resolve issues collaboratively. We are smoothly transitioning from a program office perspective to a prime contractor's perspective. The boundaries between the two organizations fade away to streamline the two-way collaboration.
You can pause,
As the
Chris.
system is conceived, it's critical.
Okay, so as we saw here, with the 3D Experience platform, what we're trying to articulate is the consistency of that digital thread from the requirements phase all the way through the whole life cycle management until we get through to production and sustainment. As you just saw, right, this provides a two-way communication between the program office and the contractor. So like Dr. Lewis and others were articulating at the beginning, that allows for visibility throughout the whole phase of development. So it's not just as I think one of the attendees had asked, it's not just uploading your deliverable at the end of your stage, right? There's always visibility throughout the whole process. This is giving that authoritative source of truth that we've been talking about, so that way you have that end-to-end requirements traceability forwards and backwards. Garrett, you want to add some more color on that?
Yeah, sure. So, one of the things that I think was brought up, and I think it was Lars and Zappos brought up was, collaboration. So when we think about collaboration, there's context of collaboration. So here you saw some cross-disciplinary collaboration pre-ASR, and that pre-ASR work necessarily establishes the product line concept. Establish the product line scope pre-ASR, what's your hope of the architecture supporting that later? And so I think that Lars was talking about UOPs. And so being able to understand that. And so when we focused on the mission and developing this narration, the mission is like a market segmentation where you're thinking about the decomposition of the product lines. And so that segmentation provides us the ability to then go back into the context of the solution across the scope of those missions and decompose it so that we understand how we're actually going to manage those product lines against the family, across the families of systems. So the families of systems establish another kind of collaboration where the people who are employing a revised AOA are doing it against the family of system concepts and then expanding into the applicability of that family of system to the new mission scopes. And so we're doing collaboration across disciplines, across life cycles, across acquisitions. And I think somebody brought up B-52. B-52 is collaborating with dead people right now who are in that re-engineering of that B-52. And so that collaboration is across multiple acquisition concepts in order to make sure that that digital connectedness is there. So I think that there's some key points in understanding that and understanding the relationship to the product line aspects and that collaboration, and understanding when we talk about MOSA, when we talk about product lines, when we talk about families of systems, we're doing things that are increasing acquisition success, right? So acquisition success is going to be begat from that scalability and reduced platform diversity. So when you look at MOSA, one of the things is you're decreasing diversity, you're increasing your ability to scale that into multiple concepts as you look at those. So this provides that sort of vision that sort of frees you up from old ways of working. And in defense of the use of ICD there, that was initial capability document, not interface control document. So just, is there a question?
Yes. In order to attain that continuous visibility into the development of the system, is the acquisition agency and the vendor both logged into the same teamwork cloud?
Not necessarily.
So let's take a step back from the teamwork cloud being the mindset and think about it more in terms of the extended enterprise. So if I do a submittal request, I'm not going to do that from something like Cameo, which is a modeling application. I'm going to do that from something where I can manage all of that dialogue with the supplier, the OEM, from the contracting agency perspective, right? And so it's not all about a single tool, it's about going across all those different operating contexts. So I know it probably doesn't answer your question, but there has to be some common system that actually people have to communicate with, either through an integration, whatever that future integration is, or some sort of a portal that allows that intercommunication, whatever that happens to be, without prescribing what that tool is. Is that?
A certain tool or system does not exist yet.
Pardon me?
Does that system or you're referring to exist yet?
Yeah, so I mean, that's part of what we're talking about here on this platform, is how to take those Cameo models and collaborate in a more controlled manner, if you will. I mean, again, it doesn't mean you have to use the 3D experience platform to do this. We're using this as an example to further the conversation about how to do a model-based acquisition. But yes, that capability is in there.
Can I foot stomp on that? It's never about the tools, ever. It's always about the data. And brother, you got that. I know we're aligned on this, but for the group gathered here. So when we're MBSE modeling, Ewing-2, the SysML standards as published is critical, okay? And extensions can be something our tool vendors sometimes give us. Got to be exquisitely careful about those extensions, okay? The other way that we do it, and that we will need to do it, are by pieces of software that provide us adapter, capabilities that allow us to use like OSLC protocols and other similar protocols to take different forms of data. Every time we do a briefing, and this happens more the more you go up the leadership stack, they want to hear a tool name. If you talk tools, you're having the wrong discussion. If you're talking about data formats and complying to that, and templates and hygiene and clarity of models and holding models to standard, particularly when you talk about being resilient over decades, we cannot get locked to a vendor. We cannot. Among other things, the vendors will shift, merge, disappear on us, et cetera. It must always be about the data and the data standards. And if we don't have the data standards, so together with our brothers in the Navy and the Air Force, we got to get the working groups and get them established wherever we can. And if Tony's got anything to add to that, foot stomp me here, brother, because you taught me this. Preach. So, it's about the data. It's not about tools. We love our tool vendors. We have some tool vendors, but you know, they're guys that we selected to solve a problem.
So a lot of that is, you're running things. Go ahead.
Okay, yeah, thank you very much, Laz. I think that, you know, you bring up a good point, and, you know, something that Dr. Lewis brought up earlier is, you know, actually, you brought up, I don't have your name, ma'am, but the interoperability is a key aspect of that, and tying it to, you know, any technical solution over a 50-year period is probably going to be a wrong or a failure of imagination. So something to think about. One of the things that we talked about was model curation. If we haven't dove into the ISO 10303-243 MOSEC, you know, it's probably prudent that we all take some time and have a conversation about that in terms of interoperability of models, not just that, and what's the metadata that helps us exploit those. So knowledge exploitation is a key factor that factors into innovation success. It allows us to increase our rate of innovation or our capacity to innovate, which was talked about earlier as well. So, you know, let's make sure we're thinking about that as well. Go ahead, we can, enough of my monologue there, apologies.
Yeah, Chris, you can restart the video.
Critical to assess in real time how well the requirements have been met through the complete requirement chain from mission to implementation. The 3D Experience platform also provides capabilities to visualize, navigate, and flag a wide spectrum of systems engineering models, including those from third parties. The platform is open and provides a way to bring additional third-party capabilities into the system. At any point in the design and implementation process, it's possible to reassess the system's ability to realize the missions. This real-time closed-loop feedback between the program office and its suppliers minimizes the risk of missing any of the mission objectives and requirements. Continuing the model-based approach, the OEM's engineers work on the detailed physical system designs, creating a digital twin of the eVTOL. This digital twin is just part of the virtual experience twin that will serve both the OEM and the program office throughout the rest of the program and into sustainment. This virtual experience twin encompasses the product twin, the production twin, and the operations and support twin to provide a complete virtual representation of all aspects of the life of this asset. The platform enables ongoing collaboration between the members of the program team and between the OEM and their suppliers. All across the value chain, models and requirements are preserved and guide every decision. When it's time for the critical design review, the OEM saves time and money by delivering directly from the platform most of the required information. Again, no need to prepare an extensive, static set of documents. The design is
Chris.
final, and the physical prototype
So just wanted to flag this point here about not needing to prepare an extensive set of static documents, right? We're evolving from this document-based mindset to a model-based environment, right? As Dr. Lewis and Nick, you know, eloquently put earlier, which I'm so glad to hear, right? It's not just about digitization of kind of antiquated analog processes or files, right? We're moving from that files and folders mindset, which was just, you know, a digital version of analog way of doing things, to models and metadata, as Garrett was just talking about, right? And also just pointing out too in this segment how the platform in this case, because we are here to talk about tools in this segment a little bit, just having that open architecture to be able to, as Garrett was just talking about, be able to evolve along with existing processes and future processes and tools, right? And not just standing still for us as a software vendor, right? We're evolving as the acquisition process and as the disciplines evolve, right? Garrett, you want to add a little bit more to that?
Probably, unfortunately for the crowd, yes. One of the things that was highlighted here that may have been subtle, and Dave Arterburns is intimately aware with this, when we conducted the MBAP, model-based architecture pilot, one of the aspirations was to make sure that we were evolving the practices of essentially e-seeders or setters or however you want to pronounce it, but the conducting of those on live data so that we didn't have the challenges associated with weeks-long preparation of PowerPoints that are immediately obsolete, so that we were operating on digitally current data. So the currency, the trustedness, the authority, all those things are constituent elements of ASOT. And if you start to pull together concept models around these things, they all tie together. And so that's something that is key, is that you're essentially increasing the rate that you can execute programs by conducting e-seeders on the actual current data that's authoritative, rather than an artifact that's instantly obsolete. One of the things that we have to think about there is that a discipline has to be evolved related to establishing proposed baselines before you go into a seeder. And so you have to be able to understand the relationship between the WIP that's conducted and the configuration management of a model of that WIP, like in Teamwork Cloud, and what you're doing at the enterprise level when you strike that proposed baseline on all artifacts that are going to be subject to critique and review during that seeder, and then collect. And there was a subtle tip to that in there. Collect systematically the RFIs, the RFAs, the notes to minutes, etc., and then burn those down as you're moving through producing that finalized baseline at whatever point in that life cycle, working on that actual data. So hopefully, and one of the things to note is this video is actually a structure that we use in conducting consulting work to make sure that we're exploring the end-to-end life cycle and values before we dive into what we're going to do in enterprise architecture. And so, think about this. We can spend, several days on a concept of big CM and little CM. Little CM being the WIP, big CM being the extended enterprise. So it's something to be aware of to help with that future architecture concept. So that's all I got there, Andrew. If you want to continue.
Yeah, we'll let this play out to the end, and then we'll just close with some of the key takeaways at the end of the video.
Okay, so super. Thanks, Andrew.
Thanks.
Prototype passes the verification and validation process. The OEM's engineering team continues to refine the design based on feedback and testing of the physical prototype. The functional configuration audit is conducted right on the platform, saving time and ensuring the latest information is used. After the production readiness review, the program is ready for low-rate initial production. Let's see how this engineering and manufacturing development phase was conducted on the 3D Experience platform. The ability to deliver the right level of mission performance is not only about the design and engineering of the eVTOL, it is also about production and sustainment. The 3D Experience platform provides leading-edge capabilities to model the manufacturing systems at any scale, from tools to supply chain, using industry-proven model-based systems engineering and 3D modeling techniques. We start with a view of the end-to-end supply chain to understand who supplies what to whom and at what capacity. The 1D to 3D digital manufacturing simulations allow the prime contractor and the subcontractors to accurately model the manufacturing processes. from stock analysis to full production line analyses. This visibility across the ecosystem will allow them to anticipate problems, optimize scheduling, and dramatically shorten the time to production readiness review. The real-time virtual twin of the eVTOL is available in the production planning process, facilitating collaboration in context between the engineering and manufacturing teams. The single authoritative source of truth and the digital thread on the platform continue to inform the development of production planning, maintenance planning, and flight simulation training, so that all these deliverables are based on the most recent designs, with explicit traceable links to their underlying requirements. Output from the low-rate initial production is tested against the systems models and requirements. The platform enables ongoing collaboration across all the teams, both OEM and program office, to address issues found in the initial production units. As the program progresses and team members move on, the institutional knowledge is preserved on the platform. When full-rate production begins, the program office and the OEM can track production and deployment on a global scale. As the first units are produced, they go into the next phase of operations and support, while the OEM continues to deliver with quality against the program orders. Let's take a look at the production planning on the 3D Experience platform. Here we've modeled the full supply chain with real-time data from each supplier to understand the global fulfillment capacity. The system indicates a need to add suppliers for metal and materials. On the 3D Experience platform, the OEM's team can identify the best sourcing and production alternatives to address the anticipated shortfall. From the overall supply chain, we now take a look at the individual assembly operations. Here, the production manager can easily evaluate the real-time performance of each station from his dashboard connected to the industrial Internet of Things. He can anticipate when scheduled maintenance may impact production. And when a defect is detected in a unit coming through the assembly process, he can assign a resource to address that production defect. The virtual twin of the factory helps visualize the production sequencing and the flow of materials on the shop floor and in the warehouse. From the receiving area, we proceed through the robotic assembly of the rotors, past the assembly area where more of the components come together, past final assembly, on into the paint shop and quality inspection. From there, the eVTOLs will be transported to an off-site testing area. With this virtual twin, all aspects of production can be studied and optimized up front, before the real-world plant is set up. The virtual twin of the product and its industrial system is also a valuable asset in developing training for the plant staff well in advance of their first shift. The virtual twin of the factory, validated and verified with virtual commissioning, increases the level of maturity and quality during the low-rate initial production. With the final assembly machine down for corrective maintenance, the production manager must find a way to minimize disruption to the production schedule. With the 3D Experience platform, he can run manufacturing simulations to find the optimal workaround and reorder the lines so production rates are minimally impacted. Once in operation, the eVTOL is used in unexpected ways. The predictive algorithms on the platform trigger an intervention in the field. They foresee a problem with the opening mechanism for the forward rotor, a problem that may be likely to occur before the next scheduled maintenance. The nearest field depot can schedule maintenance before the problem is realized in flight. Let's see the 3D Experience platform used in the operations and support phase. As the eVTOL system is now in operation, it's critical to optimize the fleet availability. And for these eVTOLs, that responsibility falls to the aircraft mechanics in the field. In our example, there's an issue with the opening mechanism of the forward rotor. Onboard sensor data and usage information for each eVTOL are collected and provide a rich cache of big data that can be mined to understand system performance and reliability. The use of data science with advanced artificial intelligence technologies on the 3D Experience platform can provide predictive analytics that dramatically improve fleet availability. The actual field usage data can be combined with the system virtual twin on the platform. Both the 3D models and 2D logical and functional designs to put all the necessary information at the fingertips of the mechanics in the field. The full virtual twin built with this model-based acquisition process provides holistic impact analysis. It greatly simplifies the introduction of enhancements to further improve the quality and performance of the eVTOL over time. The end-to-end traceability of the digital thread across all engineering domains streamlines the execution of changes, from systems design to production to maintenance, repair, and overhaul of the eVTOL. Changes that will improve new units to come or retrofits to the existing fleet. The 3D Experience platform enables a complete digital thread, an authoritative source of truth, and a truly model-based lifecycle for this eVTOL or any program asset, from mission needs analysis to optimized fleet availability. We've seen how the 3D Experience platform provides the most comprehensive, integrated, and easy-to-maintain platform to run major acquisition programs. When our troops are giving their everything in defense of our country, we owe it to them to deliver the capabilities that provide clear superiority. They can't settle for anything less, and neither should we. Don't settle for an innovation platform that delivers only a digital twin. Instead, choose the one that delivers a virtual twin experience, encompassing all aspects of the product across its entire lifecycle. The mission and the operating environment, and the experience of those who depend on the product in carrying out the mission. Don't settle for a digital thread that's actually a tangle of threads, residing in systems cobbled together with middleware, a thread that can be broken by out-of-sync software upgrades, or which can cause program delays as the various pieces must be reconnected with each upgrade. Instead, choose the only platform whose digital thread is rooted in a singular, integrated data model and can't be broken. Don't settle for a platform that wasn't designed as an integrated whole, where the cost to maintain the platform is an order of magnitude greater. Instead, choose the only platform that is designed as an integrated whole, featuring the most powerful tools while still open to other components, saving you time, money, and keeping your tools on the cutting edge. Don't settle for yesterday's approach. Instead, embrace the platform selected by the most innovative DoD programs and by the leading innovation companies who have their choice of any solution. They've chosen the 3D Experience platform for its ability to afford them greater innovation, speed, agility, and cost reduction. Our troops deserve nothing less.
All right. Thanks, Chris. Garrett, you want to speak to some of the key takeaways, or you want me to start?
Let's mix it up. I'll go first and then you can fix everything I say.
Sure.
And 2 minutes, so you probably won't get a chance based on history. So one of the things that I think is important to take away, and going back to the product line concepts, when we look at the manufacturing and sustainment pieces, if we failed to plan into the